Hello everyone, we are team number 3 and I am the first presenter, Jo Young-jun. This is our weekly study plan and we are now studying about construction parts of Lotte Tower. Last week, we studied about ACS foam. This week, following the ACS announced last time, the concrete rolling technique to fill the mold. And we studied about tower crane and lifting during lifting system. First, it is related to pumping of concrete. Higher skyscrapers require higher strength concrete construction, but it is difficult to raise concrete to target heights at once while maintaining high strength and durability. Therefore, high-rise buildings such as Lotte Tower are very important to deliver concrete. Concrete should be raised within 90 minutes of mixing because the longer the time it takes to transport and mix, the more probabilistic it can be. Especially for skyscrapers like Lotte Tower, higher strength concrete that hardens faster is used. If concrete in a liquid state that is more than twice as heavy as water is transferred through a thin steel pipe 125 mm in diameter, very high pressure is applied inside the pipe. Lotte Engineering and Construction has developed its own high-strength concrete mixing design with high viscosity and applied for the patent. It has developed concrete that reduces cement use to less than 1,000 kg per cubic meter and minimizes viscosity. It also secures flowability by using detailed grabber. High-strength concrete with 80 megapascal grade, which is 3 times stronger than ordinary concrete, was used as the main concrete used. It is the size of a die and is hard enough to support the weight of 12 adult males. If you are pushed back for a while in the middle, you will have the power to go up and down. The weight meets and the 1.2 cm thick steel tube burst. Also, pebbles or stones can break pipes in fast-moving concrete. High-pressure pumping piping and CPV concrete placement boom are required for this purpose. CPV stands for concrete placing boom and is an equipment for laying concrete in the desired location. It is mainly used when building high-rise buildings and when access to pump cars is difficult. Concrete is laid by moving to the pipe from the concrete pump located on the ground and moving to the CPV. According to Lotte Engineering and Construction, it takes 25 minutes for the construction of the world tower to push concrete up to 500 meters high with an ultra-high pressure pump. It is 5 meters faster per minute than the high pressure pump used in ordinary high-rise buildings. For use in Lotte Tower, there are 4 high pressure pumps, 7 pressure pipes, and 3 CPVs. Also, 150 megapascal ultra high strength concrete was shot up to 500 meters at a time and succeeds in vertical compression. It has secured a core technology that can build a skyscraper that is more than 1,000 meters high. It is the first vertical compression technology in Korea to shoot 150 megapascal ultra high strength concrete up to 500 meters at once. Next, let's look at the lifting facility of building materials. Lotte Tower has not only 220,000 square meters of concrete, but also 50,000 tons of steel. And we needed 5 million workers. We needed a tower crane to transport and install these components to a high-rise construction site, and a lift was needed to increase the construction capacity. From now on, let's find out about tower crane and lifting. First, let's find out about tow crane. Tow crane has two main ways. The T-type tower crane can move horizontally. The luffing tower crane features a 360-degree free rotation at its top. Among them, the luffing tower crane method was used for the frame construction of Lotte Tower. Let's look at the structure of the luffing tower crane. There are three main components. There are main jib, mast, and telescoping cage. Main jib is the same place as tow crane's arm. It has a truss structure to reduce wind loads and serves to lift building materials. Mast acts like a tow crane's leg, adding and dismantling it to control the height of the tow crane. Telescoping cage is a component that enables additional installation or dismantling of the mast on the tow crane when installing or extending the tow crane. The principles in which they operate so should be dealt with immediately or afterwards. Next, let's learn how to raise the tow crane according to the construction scale. There are two main ways: external climbing and internal climbing. External climbing is the method that increases the height of the crane itself by continuously installing additional mast as the frame rises. It is the same as the process of installing the tow crane, and the process is repeatedly extended. External climbing is a method that increases the height of the crane itself by continuously installing additional mast as the frame rises. It is the same as the process of installing the tow crane, and the process is repeatedly extended. This is the principle of the installation of tow cranes and the method of external climbing. First, raise the mast to the height of the telescoping cage. Second, operate the hydraulic system of the telescoping cage to raise the upper part of the tow crane. Finally, insert the mast that was placed in the entire process into the remaining space and fix it. It is the external climbing method to repeat this. However, this method is not appropriate for building skyscrapers such as Lotte Tower because the crane's weight continues to increase to raise its own height. Second, floor climbing is a method in which the tow crane is fixed to the building and directly goes up to the hydraulic machine. In this case, there is no need to add additional mast. In this case, it is often applied to the construction of high-rise buildings. Lotte Tower used this method. In the internal climbing method, the tower crane is first installed between the frame of the building, at which time the floor, climbing rail, and hydraulic jack are installed. Then, raise the tower crane through the hydraulic system and repeat it. When it goes up to a certain point, remove the clamping rail at the bottom and install it again at the top. Repeat this over and over during the frame construction period. In this case, there is no need to continue adding masts, which does not increase the weight of the tow crane. Therefore, it is suitable for high-rise building. However, Lotte Tower used this method to adopt a special one. Lotte Tower fixes the tower crane to the core wall during the frame construction. As the construction progressed, the crane was raised directly along the core wall through a hydraulic system. It was the first attempt in Korea at a skyscraper construction site. The actual tower crane is fixed to the core wall to proceed with the construction. In this way, only one wire was used to balance the components in the tower crane. This is because the wires can be twisted due to the influence of the wind. when working on high-rise buildings. In addition, the tower crane used a 64-ton capacity crane, the largest in the country, but it weighs only 32 tons of excess in actual construction. This also minimized the effects of wind from high-rise work and consequently solved safety construction.
Hello, I'm next presenter Jasok Che. I'm going to talk about hoist part. There are lifting machinery used in construction site, which covers tower crane, lift, hoist, and so on. First, let's take a look at the terms of lift and hoist. The lift is a mechanical facility that serves to transport people or materials to the construction site. The hoist is a part of the crane used to lift or lower loads. The equipment for transporting postpipe used at the construction site is lift. According to the regulation of the Korean law, calling lift is right, not hoist. But most construction sites call it hoist rather than lift. Before explaining hoist, I will explain hoist common tower first. Hoist common tower is a steel structured temporary tower equipped with multiple hoist lines and connecting platforms on each floor to supply construction materials, semi-finished products, and workforce to the main building. Hoist common tower operates by constructing upwards in the line with the elevation of the main building by using legs, pinions, and other things in the main building. The exterior of the building has the shape of writing brush that stands upright, and as the plane becomes smaller toward the upper floor, the gap between the building and the common tower increases toward the upper floor, which causes structure stability problems. So on the 76th floor, they join the hoist common tower and the bell truss. The first and the second common tower are first floor to the 80th floor, and the joining of the hoist common tower and the bell truss is on the 76th floor. The common tower above the 76th floor has a transition structure that moves 9.1 meter in the direction of the main building. Next, I will explain the hoist. Original lifts had a structure in which the power supply cable follows the lift. These hoists are not only deteriorated in efficiency when the height of building is higher than 300 meter, but also can cause twisting and disconnection of the cable due to wind, temperature, etc. The new solution to solve these problems is power laid lift. Power laid lifts install electric conductors on the lift's hoistway instead of cables to move the lift quickly and stably through electricity, and also electric power produced by motor as a generator during hoist force. The problem caused by cable such as twisting and disconnection have been completely eliminated. At the construction site of the Lotte Tower, there were certain hoists carrying workers and simple equipment, and all used power laid lifts that were not restricted by external influences. The power laid lift has several advantages. First, the power rail that supplies power to the lift can be stably fixed as it is fixed using a bracket to the mast. Second, in the case of the original lift, the cable was included in the lift. However, in the case of the power rail lift, the weight of the cable to the lift is eliminated and the lifting abilities is improved by 20%. Lastly, to prepare for the occurrence of the lift problem, they secure lifting data and introduce things such as smart lift information management technology and lift operation recorder. This is our weekly law. Every team member did researching. Yarim, Hyunmin, Inchang, and I make a PPT and script. Youngjun and I did a presentation. Thank you for listening.